Hi everybody, it's Mrs. Dunn again. In this screencast, what I want you to figure out is how to find values when we know some areas. So we're going to be using the TI-84 plus graphing calculator and the inverse normal function that can be found on your calculator. So I want to work through three examples. In the first example, we're going to find a percentile. Next, we're going to find a test score. And then finally, we're going to find a critical value. So a percentile in the first example, then a test score, and then a critical value. We're going to do this all in our calculator. So for example, if we want to find a percentile from a non-standard normal distribution, let's look at an example of that. So non-standard, remember means that the mean isn't 0 and the standard deviation isn't 1. So the heights of adult women are normally distributed with a mean of 63.7 inches and a standard deviation of 2.9 inches. Find the 95th percentile of heights of women. That means that you want to find the height that separates the shortest 95% of the women from the tallest 5% of the women. A picture will help with that. So that means this area, see, in this problem, if you looked at my previous two screencasts, you realize that in this question, we're being given the area. So we know what the area is. What we're looking for is the z-score. Well, it's not a z-score here because it's not normal. We're looking for that height that is going to separate the top 5% of the women from the bottom 95% of the women. So this area in white is the 5%, 0.05, and the area in green is 0.95. We're going to be using our calculator in the inverse normal function on there. The syntax is we put in the area, that's going to be 0.95 for us, the mean, the standard deviation, and then we tell the calculator if that area is to the left, to the right, or in the middle. Now, I have to point out that not all calculators allow you to do it this way. In the newer calculators, they're a little bit different, so I'll address that in a minute. But here's how we do it on the newer calculators. So on our graphing calculators, we're going to find that inverse normal function. So press second vars again and find inverse norm. It's asking us for the area. In this problem, the area is 0.95. The mean in this problem, remember what that is, 63.7. And the standard deviation is 2.9. Now, we want the area to the left. So I'm going to tell the calculator to find the area to the left. And I'm going to paste that in. It looks like this on the main screen. And the area, the value, that x value is approximately 68.5. So that means that 95% of all women are shorter than 68.5 inches, and 5% of all women are taller than 68.5 inches. Those calculations that I just did on the newer calculators I've summarized here. Now remember, if you're using an older TI-83 or an older 84 calculator, when you use that inverse norm, the area that you put in has to always be to the area to the left. You don't get that left, right, or center region option. So the syntax is 0.95, the mean 63.7, and the standard deviation 2.9. This area must always be the area to the left. All right, second example. In this example, we're being asked to find the 95th percentile. And this one is a standard normal distribution. So this one is normal. The notation is a little bit different, you'll notice. So in this one, the notation that you use is this 95th percentile. Once again, a picture helps, and we're finding that area 0.95. So this is going to look very, very similar. The only difference is when we're using this inverse normal, the area is 0.95, but remember we have a standard distribution here. So in this standard distribution, the mean is 0, and the standard deviation is 1. Still need to put the area to the left. And the z-score that corresponds to that area is 0.1645 approximately. On the older calculators, the notation, the syntax, is going to be inverse norm, left area, mean of 0, standard deviation of 1. All right, lastly, we want to find a critical value. A critical value is a score that separates the very, very low z-scores from a very high z-score. So in this example, where we're finding z of a subscript of 0.01, that subscript 0.01 represents the area to the right of the z-score. Those previous two examples had an area to the left. In this one, we're using an area that's to the right. Please make note of that. The area, therefore, to the left is going to be 1 minus that subscript, 0.99. And the area to the right is 0.01, because remember that area has to add up to 1. This stuff we're doing right here with these critical values, these critical z values, these are going to become increasingly more important once we do chapter 7 and 8. All right, once again, a picture helps. The area to the left is 0.99. The area to the right is 0.01. Remember, know your calculator. The newer TI-84s are going to work and look the way mine do. The older ones require you to put the area to the left, so please make sure you're paying attention to that. All right, so let's look at how we do this on our calculators. So, second distribution, inverse norm. The area that we're going to put in my calculator is 0.01. That's the subscript. The mean in this case is 0. The standard deviation is 1. And we remember we want the area to the right to be 0.01, not the area to the left, the area to the right. Press enter and paste that in there. And that z-score is 2.33 approximately. If you're doing that on the older calculators, let me clear this and show this to you. On the older calculators, when you press second distribution and the inverse norm, remember this wizard doesn't show up that helps you put that information. You have to put it in yourself, separating with commas. So on the older calculator, you're going to put the area to the left. The area to the left is 1 minus that 0.01. So you can type that right like that in your calculator, 1 minus 0.01. Older calculators, comma, 0, comma, 1. And older calculators are actually finding the area to the left. I just wanted to do this again to show you that you get the same answer, 2.33. All right, good luck with this section. Good job so far.